Hello friends, today I will be explaining you about the pin configuration of 8086 microprocessor. Okay, it is important to know the functionality and importance of each pin, because if you know the importance, then only you can connect the other peripheral devices like the IO device or the memory device to the processor. So we will see about these pins in detail. Mainly the first thing you need to know is that the 8086 microprocessor can operate in two modes, the minimum mode and the maximum mode. Okay, so now here there are 40 pins, 20 at each sides. Among these 40 pins, there are some pins that provide the same functionality during the minimum as well as in the maximum mode, and there are some other pins like you can see from 31 down to 24. These pins provide these particular functions in the maximum mode and these functions during the minimum mode. We'll learn about each of these functions. So starting with the AD0 to AD15, that is from here AD0 to 14 and this 15. These are known as the multiplex lines. Why multiplex lines? A multiplex line is the one that carries multiple forms of information. So as you can see here, the A contains the address and D contains the data. So it contains address and data, the multiple forms of information. So they are called as the multiplex lines. Okay. Now these lines, how they are used is actually we use an ALE pin along with it, that is this ALE pin. When this ALE pin is set to 0, this AD0 to AD15 is used to carry the data, and when this ALE pin is 1, we use this AD0 to AD15 line to carry the address. Now suppose this processor, it wants to connect to another device. So what it does is during the T1 cycle, it sends the address of the device to which it wants to connect using these pins. Okay. There are in a clock cycle there are 4 stages: T1, T2, T3 and T4. So during the T1 cycle we transmit the address, and during the remaining 3 cycle we transmit the data. Now moving on to the next pin, that is A16, S3, A17, S4, A18, S5 and A19, S6. So these pins are used like when as you can see, these are time multiplexed address and status line. Again multiplex, it contains multiple information, that is one about the address and the other is about the status. So during one cycle, this A16 to A19, they carry the upper 4 bits of address data during the T1 clock cycle, and otherwise during the IO operation these lines are set low. Okay, so this S3 and S4, these are the status signal. They represent which segment the processor is currently accessing. So you can know about that in detail from here. This is S3 and this is S4. So when it is 0, 0, the processor is accessing the extra segment. When it is 0, 1, it is accessing the stack segment. When it is 1, 0, it is accessing the code segment or none of them. And when it is 1, 1, it is accessing the data segment. Now coming back here, you can see the S5. S5 is an interrupt signal, and S6 it is reserved for future use. So during all the time this S6 is set to 0. Then next we will be seeing about this BHE S7, that is bus high enable, and S7. It is used along with the A0. It represents what type of data the processor is presently accessing. By the type of data, what I mean is whether it is accessing a byte or a word. So you can see it in detail from here. BHE bar and A0. So when both are 0, 0, the processor will be accessing a whole word from the event bank. Now it has got two banks, an even bank and an odd bank. So when both are 0, 0, it will be accessing a word from event bank. When it's 0, 1, it will be accessing the upper byte from odd bank, and when it's 1, 0, the lower byte, it will be accessing lower byte from the even bank, and when it is 1, 1, it will be accessing nothing. Okay. Then next we will look for the pin number 32, the read pin. It is an active low signal. It is used by the processor to indicate that it is performing a read operation with memory or the IO device. Now how we will recognize whether it's memory or IO, it can be done using this pin. We will see it later. Then next we are going to see about this ready pin. Ready pin is used by the external peripherals to represent their status, that is whether they are ready or not. So when this pin is set, it means that the external device is ready to accept or transfer the data, and when it is 0, it means the external device is not ready. Then we have this test signal, test or the BZM. It is used along with the wait instruction. So whenever wait instruction is executed, the processor will monitor this pin continuously. So if you see that it is an active low signal, so when it is 0, it means that the processor can continue with its execution, and if it is 1, the processor remains idle for that state. Then next we have this reset signal. What is it is when this signal, it is an active high signal. Okay, so when this signal goes high, the processor enters into reset state, that is it terminates all the instruction that is currently being executed, and it start the execution again from FFF0H, that is the initial state or the predefined state of the processor. So this signal must be active for at least 4 clock cycles. As I said, a clock cycle has 4 states, so it must be active for at least 4 clock cycles. Okay. So now moving on to the next pin. Now we see about this 18th pin, INTR, that is the interrupt pin. It is a maskable interrupt. By maskable, what I mean is it is a user control interrupt. That is, the user can enable or disable the interrupt. If this interrupt is enabled, the processor will recognize the interrupt and it will provide the service to that instruction, the interrupt that has occurred. Suppose we disable this interrupt, the 18th pin. If we disable this interrupt, then if any interrupt occurs, the processor is not going to recognize it and it will just continue with its own execution. Okay. So this pin can be enabled or disabled using an interrupt flag which is inside it. Next we have this NMI on the 17th pin, that is a non-maskable interrupt. It is also an interrupt, but it is non-maskable. That is, they are not controlled by the user. It cannot be disabled by the user. So whenever an interrupt occurs at this pin, then the processor must and should respond to this interrupt. Then next we have this clock at the pin number 19. So what this clock does is all the internal blocks, it gets synchronized with the help of the clock signal. If there are no clock, then there will be no synchronization between the processor and the other components or devices. Then we have this VCC and ground. There is one VCC and two ground over here. VCC, it can range up to 5 volt and ground is, as you know, 0 volt. Now we will be seeing about the minimum mode pins and the maximum mode pins. Okay, so first we'll move on to the minimum mode pins. You can see at this pin number 33, this MN MX bar. This is a min max pin. Means this pin is used to set the processor to a minimum mode or to a maximum mode. So when this pin is connected to the VCC, the processor will operate in the minimum mode, and when this pin is connected to the ground, the processor will operate in the maximum mode. So first we will move on to the minimum mode pins. So these are the pins that will be operating in minimum mode, and these are the functions that will be operating in the maximum mode. So here you can see the M IO bar at the pin number 28. You can see M IO bar. It indicates the processor will be performing operation on which device, like memory device or the IO device. So when this pin is set to 1, that is when it is equals to 1, the processor will be performing operation with the memory, and when it will be 0, the processor will be performing operation with the IO. By what I mean by perform operation with the memory is that whatever read or write operation will be performed, it will be performed on memory, like read from memory or write into memory. Similarly for IO. Then next is the INTA bar. This is an active low signal. It is an interrupt acknowledgement signal. Whenever an interrupt is generated by this INTR, its acknowledgement is sent through this pin. Then next we have the ALE, that is the address latch enable. This pin, the main function of this pin is to differentiate the address from data on the multiplex line. As I said, in the multiplex line it contains address as well as data, so the address latch enable pin is used to differentiate the address from the data. So when this ALE is 1, it carries the address information, and when the ALE is 0, it contains the data information. Then we have this data transmit or receive, DT/R bar. It is a data transmit or receive signal. So the main, when this pin is set to 1, we say that the processor is transmitting the data. It is set to 1, so it will be transmitting the data. When it is 0, then R will be high. So when it is 0, the processor will be receiving some data. Then we have this DEN bar, that is the data enable. It is an active low signal and it is activated to activate all the data buffer inside the processors. So it also indicates valid data on the multiplex line. As you know, this ALE, it indicates the valid address, so the DEN, it indicates the valid data. Then we have this hold pin, HOLD, hold, at pin number 31. So what this does is, now suppose there are multiple processors or there are multiple masters, okay, so who are accessing the same data system, who wants to access the system bus. Now suppose this one is accessing the system bus and there is a DMA controller that wants to access the system bus. So what it does is, that master will request this master or original master or the processor by using this pin, hold pin, that I want to get a hold on the system bus, and its response will be sent, that is this original master will send the response to the requesting master by using the hold acknowledgement pin. That is the work of this hold and HLDA. This WR bar, it is an active low, it is used to write the data. Now moving on to the maximum mode pins. So these are maximum mode pins. When this MN or MX bar, it is connected to the ground, the processor will be operating in maximum mode. Okay, so you can see this S0 bar, S1 bar and S2 bar. I hope it's visible, right? Yeah. These lines, they represent the status line. Status is the type of operation carried out by the processor. You can see about it here. Okay, this is S0 bar, S1 bar and S2 bar. So when it is 000, the status will be interrupt acknowledgement. When it is 001, it will be IO read. When it is 010, IO write, 011, halt. Halt means it is not doing anything. And when it is 100, the opcodes will be fetched. 101, it will read the memory, and 110, it will write into the memory. And for 111, it will be passive. Passive means idle state. Now next we are having this R0, GT0, RQ, G2, GT1. Okay, this is a request and grant signal. So in case of maximum mode, as I said, in maximum mode, it is also known as a multiple processor mode. That is, multiple processor can execute. Okay, so in maximum mode, if there are multiple processors are connected to each other, and if one of the processor wants to access the system bus, as you know, the system bus can be accessed by only one processor at a time. So whenever there is some other processor that wants to get access to the system bus, what it does is, it requests the processor currently holding the system bus using this pin. Okay, so this is a bidirectional pin, that is the processor request for the system bus using this pin, and the processor that is currently being holding it sends the acknowledgement using the same pin. Then next we have this log bar. It is an active low signal. It is used when the processor wants to log the system bus. That is, a processor is currently using a system bus and it does not want that any other processor should get access to that bus. So what it does is it logs the system bus for a particular duration up till the time when it finishes its execution. So that is the purpose of this log bar signal. And then we have this QS0 and QS1. They represent the status of the instruction queue. By what I mean by the status of the instruction queue is this QS0 and this is QS1. So when it is 00, it represents that there is no operation to be performed. So when it is 01, it means the first byte of the opcode from queue. That is, it will be executing the first byte of the opcode. When it is 10, the queue will be empty. When it is 11, the subsequent byte from the queue means there are more opcodes or the bytes that are needed to be fetched and executed. So there are more data in the queue. So this was all about the pin configuration of 8086. I hope you all understood it. Thank you.